very much. Thanks. Thanks everyone for spending some time this afternoon and learning about SBCs, and specifically SBCs in the cloud and virtual security. So before we get started, I'd love to do is find out what, I don't know, skill level or where you folks are in the process. So tell me, how many of you already deployed SBCs in one way or another? Okay, a good few of you. How many of you done it in the cloud so far? All right, a few of you. Good. That's very good. Good. Well, if anywhere in here during the Q&A session, if we have time, if you've got a case study or a story that you'd like to share with the rest of the group, for those you have deployed, you know, obviously raise your hand at the end. Hopefully we can squeeze in some of that. I think that's always best when the people who bring all the knowledge to the table get to share. So anyway, yeah, so I'm Alan Percy. I'm the senior director of product marketing at Telco Bridges. I joined the company about a little over a year ago, and I've spent quite a bit of time in some of the other big players in the session border controller space, either in product marketing or in technical roles. I spent the first 15 years of my career developing software. I started in avionics and then ended up in telecom. How that happened, I don't know. But and it was kind of fun listening to Mark talk yesterday about software and avionics. It's like, no, software and avionics is nothing like this industry. So I got sort of a kick out of that. Anyway, so I joined Telco Bridges last December, and with a special focus on our free SBC offering, which we'll use in a couple of use cases in here. But this is general information about putting SBCs in the cloud and what the roles and responsibilities are. So hopefully get a lot out of it, and I look forward to your questions. So first of all, I just want to quick review what are some of the risks that you all are probably facing, especially if some of you are probably offering hosted services to your customers. That's obviously becoming much more common. So there are whole classes of risks that folks, matter of fact, at lunchtime shared with me some really great stories. But extortion is a big one. Extortion basically meaning if you don't pay me, I'm going to take out your service. And if for a hosted service, it's very, very important, right? Every minute you're down, you lose revenue from your customers. Customers get pissed off, and it's a real problem. And some classic ways to do that is denial service attacks, registration floods, and that's where they repeatedly attack through registrations, complex registrations. Malformed SIP headers. We'll talk about. Actually, a story about that. That was somebody volunteered that at one of the previous sessions a few years ago. And then call attempts per second, right? They basically hammer your network with call attempts, and that basically trashes it so nobody else can use it. Then there's intrusion, right? This is trying to actually break into the servers, figure out passwords, somehow get access to the server itself. Through network scanning, and of course the theft of services, meaning somehow figuring out a way to hairpin a call through your service and be able to make phone calls to Liberia. That was the story here at lunchtime today. Somebody got a $64,000 phone bill due to that. So, and of course the open source community has got sort of an interesting twist on this, because the good thing about open source is you get source code, which is awesome, right? You can fix almost anything, but there's one big problem. The bad guys get source code too. And one of those cases I talked about earlier is particularly important, because that's how this particular thief or fraudster figured out that a certain malformed registration would cause Asterisk to crash. So he basically remotely, using that malformed message, could figure out what version Asterisk somebody's running. Based on that version, he could send a registration request and crash the Asterisk servers at will. And so that's how he extorted money tried to extort money from one of the partners a few years ago. So they're real. These are very real risks, and there's really bad people out there who really would like to mess up your day. So how do you protect yourself against them? Well, session border controllers is a key piece of should be a key piece of your security model. And we're going to spend just a couple of minutes talking about what their jobs and roles are, but they really are, for most folks, sort of envision it as a crossroads of the networks. They originally were offered to the market as an edge device, and that's why it's called session border controller, an edge device to put between networks, and you'll see in the use cases where it is. But it's turned out that they've become really the crossroads of networks and have many, many responsibilities and roles. And then a couple of slides from our sort of SBC 101 deck, just to get us all on the same page. The roles of a session border controller certainly are security, and they fall into a couple subcategories. Topology hiding is a key one, and we'll talk about what that is and how it works. Intrusion protection, certainly blocking someone who's trying to hack into your network. Encryption, which is either encrypting or decrypting, and I'll show you how that works in a moment. Interoperability, resolving disconnects or interpretations of the RFC 3261 from one flavor to another, and that's one of the beauties of SIP is it's flexible and can be adapted to many different uses, and that's also its worst curse, is that there are so many different flavors of SIP, and it seems like virtually every service provider has their own flavor, and you have to do dial plan fix-up, or you might have to do header manipulation to fix those things. And of course, routing and traffic management, a call comes in, it's a perfect time to decide, well, based on this call and the dial number or where it came from, I'm going to route it to a certain place or do load balancing or other responsibility. And as long as you have the call, why don't you scrape the information necessary for billing, right? Start time, end time, dialed number, etc. So it's really ended up with all these other responsibilities, including media services, converting from one codec to another, or terminating or substituting media, announcements, etc. So all this functionality has been jammed into one basic function for the network, and it has evolved over time. So let's just dig into a couple of these things. So topology hiding, this is where you really don't want your IP addresses of the inside of your network, your service provider network or enterprise network, to be exposed to the outside world. And it's not as simple like a firewall where it can just substitute with a NAT. It's much more complex. There are IP addresses that get buried in some of the SIP header messages, and of course the media similarly. And when this role of a back-to-back user agent is a critical piece of what makes an SBC work. And this is where a session terminates at the SBC, and the SBC reinitiates a new session on the other side with the new IP addresses. It plays a critical role in the topology hiding because somebody's hack can't get past this border, right? Because that call gets terminated at the SBC, and there is a new session built on the other side. So topology hiding is one of the key basics of an SBC. A little bit more complex then is intrusion detection and prevention. And this is the various bad guys, either somebody individually or bots or denial of service attacks. I think you folks are probably familiar with this from firewall applications. And the role of the SBC is to detect these and to block them. And it could be as simple as, gee whiz, we see a lot of requests from this one IP address and it's unusually frequent, to malformed messages landing at the SBC and it preventing them from passing into the application. And by the way, the application on the right, and for all purposes in this conference, is asterisk or one of the asterisk derivatives, right? One of the applications. So this is a key set of responsibility. How it does this and the mechanisms and what SBCs protect against is a little bit of a black, dark secret because we don't want the bad guys to know exactly how we do it. But these are methods that are used to detect and then stop fraudulent attacks in a network. Encryption demarcation. This is another area that SBCs play a valuable role in that as SIP trunking and some of the other services like WebRTC and others are becoming more popular, it's becoming much more of interest to have fully encrypted not only session but also media out in the public network. Right? No one likes to hear these stories or proposed stories of important phone calls being eavesdropped over Wi-Fi, for example. And by encrypting the media stream, you could obviously protect those, but when they get to the edge of a service provider, to help with scaling and other functions, it's best to convert that call from encrypted to clear, right? To basically decrypt the call and the session so that all your infrastructure inside your network, either an enterprise or a service provider, can be in the clear without encryption. And this makes those applications on the right much more efficient. So this is very common in contact centers. It's very common in hosted applications to have them be in the clear and the SBC's job is to do decryption at the edge. Okay, so media services, and this is generally most common is probably transcoding. This is the conversion from one voice codec to another, and this is fairly common with some of the service providers like AT&T support G729, which is a compressed voice format, and convert it back to G711 for these kinds of applications. We're starting to see this a little bit more and more with WebRTC, because WebRTC has a really good codec. And that codec, when it hits IVR platforms or contact centers, they like to have everything in G711 because that's where all their speech engines are coded to use G711. So the conversion of one codec to another, transcoding, is important. But it also falls into other little esoteric things like DTMF detection. And one of the weird things about SIP is there's 3 or 4 different ways to pass DTMF from one endpoint to the other. And one of them includes in-band tone. When you press the key on your phone, of course, in-band puts DTMF in the audio stream. And then the applications don't like that. They like it as a separate SIP message, a SIP info message, for example. And so the SBC plays this role in detecting that tone, clamping it, taking it out of the audio stream, and delivering it instead as a SIP info message over to the application. Another one I point out here too is legal intercept. It's not uncommon for an SBC to also play a role in capturing the audio stream that might be being passed through it for legal intercept reasons, meaning CALIA or law enforcement who would like to record a particular call or track the call flow traffic from one particular bad guy they have a warrant against. So it gets involved also in legal intercept in actually not only capturing, but also forking a copy of the call and sending it to a second location. And that's what that last little graphic is. Okay, so now let's get into interoperability. So this is done by a lot of, most SBCs is they have to do some kind of, as I mentioned before, some kind of header fix-up or cleanup. Digit manipulation is one where, for example, here on the left, a call comes in and it's only this 7-digit number, and then to pass it along, it adds the the +1 and the area code. That happens very common in Microsoft applications, for example. They like to have the full plus telephone number. Privacy notification, where they might strip off a caller ID on one side and pass it as anonymous on the other side, or vice versa, put headers on it. Customized headers, we see this all the time where certain applications like to use X headers and other functions, instead modify it to a different SIP header or eliminate it altogether. And of course, some protocol conversion. There are cases where SIP might come in on TCP and will need to leave on UDP on the other side. So sometimes those are handled. And again, these are configuration from one service provider to another, or one application to a service provider, or between different applications. We see this, and I'll show you an example in our use cases in a few minutes where that happens. And then traffic management and routing. And this, as I hinted before, can be load balancing. It can be based on dialed number. It could be, a perfect example would say, let's say you're building a conferencing service on the right. In those conferencings, right, you like to have the parties who are trying to conference between each other on the same server, so that that conference call occurs on the same server. It eliminates a lot of traffic on the network. So if they dial the same access number, you would send them to the same conferencing server, and that conferencing server would then service their particular request. But there's a whole host of reasons why you would route calls, from calling number, availability, which one of the servers is up versus down. And then there are also external third-party algorithms. For example, least cost routing and some other fraud detection algorithms as to where do you route these calls and how do they get routed. So let's move on from that, and let's start to talk about some of the use cases. And the use cases of what I brought here are situations where the cloud is somehow involved. Right? There's tons of use cases for SBCs, but these are have somehow are affected or effective in the cloud. And the first and most simple one is just peering. This is between two service providers. And just out of curiosity, how many of you folks are doing service provider applications? All right, enterprise, the rest of you? Not sure why I'm here in the room? I don't know, just checking, just making sure. All right, so service provider applications, it's very common for a small regional service provider, a tier 3 service provider, to use wholesale operators, right? He doesn't have the infrastructure to send calls halfway around the world. He has to use a wholesale operator to make it happen. So the wholesale operator might be level 3 or AT&T or one of the big guys, the tier 1s. The right is a small regional service provider. And that interface between those two, generally you would have an SBC on both sides of that. Now they don't necessarily need to be the same brand. They could be different manufacturers. And they often are different manufacturers. And there are certain roles and responsibilities that those SBCs are tackling. If the service provider on the right, for example, is a cloud-based service provider, maybe they're offering cloud-based conferencing, for example, that SBC would be in the same cloud infrastructure as the conferencing server. All right, and we'll in a few minutes we'll talk about some of the challenges that deployment has. But basically that SBC is on the same subnet within the cloud environment as the application, and maybe would also be driving a billing system that would be in that same cloud infrastructure. And we've got some customers deployed in this particular model, and it has some security enhancements and some challenges. Okay, so this is a typical kind of use case. We see it all the time. I talked to a customer last week who's doing exactly this, where that cloud is actually Amazon. Okay. Another one is hosted IP-PBX, a similar sort of model to the right. This service provider might be, it could be Asterisk, it could be FreeSwitch, it could be any one of a number of different platforms. He's using an SBC to protect the connection between his customers, which have IP phones, maybe out between at an IED or a router out in an enterprise, and that SMB enterprise. Those devices need to register to connect in, and of course, connect to the soft switch. So some of the tasks or responsibilities are, denial of service protection, NAT traversal, registration pass-through is a key thing, analytics and billing. And one of the challenges here is you don't necessarily always know the IP address of where these SMBs or enterprises are, especially if those phones are work from home. So it's not like you can use, a firewall to cap the IP addresses that these people are coming in on. You have to basically leave it pretty wide open because you don't know where these customers are coming from. And the SBC has to look at these registrations that are coming in, and based on the registration, then allow traffic on that from that IP address, and to allow that particular phone or device to have access to the application. Another popular use case is redundancy. And actually, I talked to a provider a few weeks ago. They have this exact scenario. They've actually got FreeSwitch in the Amazon on the right-hand side here. And so again, he's got a cloud infrastructure on Amazon where he's got 2 FreeSwitch servers in the cloud, and he's using SBCs to front end of those 2. With the intent of working with multiple wholesale, he has multiple wholesale providers, and the idea is that those cross-hash lines, the dashed lines in there, are his redundancy patterns. So the SBCs are playing a critical role in detecting maybe one of these FreeSwitch servers if they go down, or he has to take them down for maintenance. He can redirect traffic based on availability from either wholesale provider to either of the 2 soft switch platforms, and can redirect the traffic dynamically or load balance it between the 2 if he so chooses. Meanwhile, sort of measuring the performance and making sure that the servers are up and alive and performing traffic. Again, these SBCs are in the same subnet, and it has some benefits and some challenges. Okay. So I think one last use case, no, it's actually one more after this, but this is also a contact center. And this is, they're going to have multiple SIP trunk providers. And in the center of the core, we've got a dialer or an ACD. And they're, of course, going to be using a SBC to provide connectivity between the dialer and the SIP trunk provider, maybe resolving some interoperability, but they also might have some work-at-home agents on the left-hand side there. So there's some challenges there. There's one situation is he's using the SBC to talk to SIP trunk providers. There's another situation where we're maybe using the SBC to protect those work-at-home agents, or there might be a separate SBC to manage those work-at-home agents. Again, the application and the SBC are in the same subnet. Here's a little different one. This one's an interesting one. I learned about this one a few weeks ago. So now with the emergence of CPaaS providers, any of you working with a CPaaS provider yet? Okay, a couple of you. All right, so CPaaS, it's communication platform as a service. It's a markup language, scripted platform that allows you to write scripts real easy. You can write, you know, dialer scripts. You can call people. You can answer calls, do IVR. Very easy, very straightforward. Twilio is a perfect example of it. There's Plevo and Nexmo, and there's, you know, a dozen of these guys that are out there. And they love to offer their customers turnkey, not only use the CPaaS platform, but they love to offer SIP trunks to the customers too. The problem is for some enterprises is that they would love to use these CPaaS platforms, but they already have a SIP trunking provider that they've been working with for quite some time. So what they end up having to do is put an SBC to do interoperability between the CPaaS platform and the SIP trunking provider, to do some SIP header fix-up and correction. In this particular example here, we see they had to resolve the domain name mapping between the Twilio platform and the SIP trunking provider. So they had to do the fully qualified domain name mapping and to do some call routing because there's multiple SIP trunk providers. But they also didn't want the media to go through the SBC. They wanted the media to go around the SBC, and they want it hosted in the cloud. In this particular case, the customer had two providers. Twilio's already got their own cloud, and you know, you go walk up to Twilio and say, "Hey, will you run my SBC in your cloud?" And they told him, you know, beat it, no way. So he had to host his SBC in his own separate cloud instance, independent from those, from the CPaaS platform, and of course, independent from the SIP trunking provider. So he had to find an SBC that could go into the cloud and operate independently on its own. And one note about this is, since they're on different cloud platforms, of course, they're on different subnets, right? So now we've got kind of an SBC just sort of floating out there by itself in the cloud. So how do we deploy all this? And we've showed, you know, obviously a host of these use cases. How does it get deployed? Well, first of all, you know, there are some significant changing economics in the telecom industry, as I'm sure you guys know. You know, the old way we used to sell stuff, it was hardware-centric. We sold a box. There was proprietary devices. I'll give you a couple examples in a minute. And then down the road, the hardware would get obsolete, and we would have to replace it. And there was this huge capital expenditure and maintenance fees. And the total cost of ownership was very steep in the beginning when they bought it, and then there was a maintenance fee over the years as they went by. You know, the cloud world and the cloud way is a very different model. It needs to be software-centric. It needs to be on COTS hardware, be virtualized or work in the cloud, and offer software as a service, and a pay-as-you-grow model so that these agile hosted services can be deployed quickly and cheaply. They start to build a subscriber base, and as their subscriber base grows, they can now start to charge and build a revenue stream, a reoccurring revenue stream on top of those customers to get their costs back. So it really requires a very different business model than the old telecom way. And this is really wrenching the telecom equipment market, and especially wrenching what's happening in the SBC market. And spoke with Diane Myers a couple of weeks ago. She works for IHS Markit. She follows very closely in the service provider equipment space, and she has a quote here. Service providers have been deploying session border controllers predominantly as standalone devices, but by 2019, they're going to implement SBCs as software in virtualized environments and in commercial servers, and that's part of one of her analysis of the market. So she sees this trend starting to happen. It's going to software in virtualized environments. Our friends over at the Eastern Management Group gave us a slide here talking about hosted PBX shipments. And this basically is saying is that as hosted PBXs are becoming more and more popular, or you know, it's showing that people are moving to hosted environments from traditional CPE environments. And of course, with that comes the need to protect those applications, and SBCs get pulled through as part of a hosted PBX deployment. And lastly, our friends over at Exact Venture share with us that they, from their forecast, see the session border controller market going from, obviously in the past it was 100% physical appliances, that now in 2017, 18, and 19 is this huge transition to virtualized software and cloud-based SBCs. Eventually, by 2022, it would be 75% of them will be virtualized or cloud. So this trend is very clear that the SBC market's moving to a software and cloud environment. So SBCs back in the day, I don't know if any of you folks, do anybody recognize this box? Anybody want to volunteer, take a quick stab at it? It's a big old Acme box. It's the old Acme SBCs. And it was dedicated, specialized hardware. It was not COTS equipment by any stretch of the imagination. It had specialized boards for packet processing, specialized DSP modules in it to do that media conversion we talked about. It was based on DC power, 48 volts DC power, good old central office gear, and very high availability hardware. And it came with a price tag that went along with that. It was very, very expensive equipment. And this is the majority of what's in the telecom network today. The VoIP-based telecom network today is this gear. This is Exact gear, as a matter of fact. They have a dominant position in the service provider network. But there are other ways to skin the cat, and this is what we're starting to see, right? Deployments in COTS servers, whether it be high performance servers in a data center, to small CPE appliances that might go out at an enterprise site, using COTS server technology. And of course, the benefits of this is, we'll compare all these as we move along here. But it's dedicated hardware, but then again, it's COTS hardware, so it has the benefits of the low cost scale of COTS hardware. What we're seeing more and more is virtualized environments, and part of what's driving this is this ETSI NFV framework. So I'm just out of curiosity, how many folks have worked at all or spent any time studying NFV yet? Started to look at it a little bit, okay? So that's network function virtualization, and this is something that ETSI basically formalized, where the various functions of a network, routing, firewall, session border controller, there's other functions, if they virtualize those network functions, they become virtual network functions, or VNFs, then they fit into an architecture called a network function, the NFV, Network Function Virtualization Framework. I know it's terrible naming because it's the same letters in different order, but virtual network functions are basically the software necessary to perform that function that runs in a virtualized environment that can be plugged in as a module in the upper right here and orchestrated or managed by a set of consistent software. So as a service provider, they can say, I want to add more SBC sessions. Through orchestration, they can initiate extra virtualization software to be started to run that function on their networks. Terribly complicated, but the net result of it all is that they're able to now deploy this software very quickly, very remotely, with a lot of flexibility. And the key platforms, VMware, we see as by far the 60–70% of the downloads that we see are VMware-based. KVM is very popular. KVM, matter of fact, is the platform that's used in this NFV environment with OpenStack for orchestration. Has a bunch of benefits from flexibility, but has one big problem. It's not really very efficient. And any of you know from working with VMware or any of the other virtualized environments, there's a huge tax of running in a virtualized environment. You basically piss away 20% of your CPU cycles to the virtualization infrastructure. And that limits the scale that you can run these kinds of things within. So pro, con, right? Pro is you get a lot of flexibility. Con is you just paid a 20% tax on your silicon. Third one, of course, is just cloud, right? And and we've kind of been studying the market and watching what people are using for cloud. AWS is obviously hugely popular, but Microsoft is there too, and Google, IBM, and a handful of others. But AWS and Amazon is super popular. How many of you folks here use Amazon or AMI? Do Amazon Cloud, right? So, just out of curiosity, how many of you do Azure, Microsoft Azure? A few of you, yeah. Yeah, it's pretty popular, and obviously some of the other folks should get into it too. And it has a huge set of benefits, right? So it's pay as you grow. You pick a platform that supports what you need today, and as the time goes on, you can either add more platforms or move to a bigger platform. It's tremendously flexible scaling, but there's a couple of big cautions in here. One of them is the media charges. You really have to watch these, the media charges. Anyone get socked with those yet? Yeah, we got one in the back. And basically, with each one of the Amazon choices, or instances they call them, there's a certain allotment of the amount of traffic that you can send through it. You go over it, it's just like your data plan on your phone, and zowie, they get you. And you have to really plan and manage the traffic that goes through them, the throughput caps. And the last one too is the noisy neighbors problem, which is you really don't know, if you're not using a dedicated server, what your neighbors are actually doing. And if they're doing a lot of high-speed packet transfers or maybe large file transfers, they may affect the throughput that you're able to get through your shared resources. And noisy neighbors can cause some problems, and sometimes people have to move to dedicated hardware, which kind of cuts some of the the financial benefits of moving to cloud. Because now all of a sudden you're paying for your own dedicated piece of hardware in a cloud environment, and you lose the shared resource economy. So just a quick comparison between them all. The appliance, by far the highest performance. It's very predictable. You don't have to worry about your noisy neighbors or the unpredictability. You have the option of doing CPE appliances with dedicated hardware. It's great for really large scale and private data center. If you're building out your own data center, appliances are a really still very valid way of deploying these kinds of applications. Virtualized. Real flexible, we talked about that, the previous one. What's great about it is you can build service change, which is where you put firewall, router, SBC, applications all together in a virtualized environment. You can orchestrate them, and they all interface within each other in this virtualized environment. The only thing is the VM overhead does really limit performance and predictability, so you have to be careful with load testing and other areas like that to make sure that you don't overexert or overcommit those resources. Cloud, really a big benefit is pay as you grow, but again, huge caution. Media charges, watch it. Watch for noisy neighbors, and in detecting noisy neighbors is voice quality and jitter, and you're measuring those kinds. So you have to have some way of measuring your media performance to make sure that you're delivering the service that people expect. And it's great for dynamic, fast-growing companies. But I think it's important that you're keeping track of the media performance to not disappoint your customers. So what are the rewards of moving to the cloud? This low upfront cost, pay as you grow, scaling, time to market, and infrastructure in region. I've skipped over this. You can now, with Amazon and Microsoft and the other platforms, you can put a server in Timbuktu, right? You can put something out in Turkey, for example, and sign customers up and remotely manage it from here. And that server sits out in a regional data center providing media services to those customers. What are the risks? One big thing is the cloud infrastructure outages. It's sort of interesting. When I was doing some reading about this, they happen. Microsoft in Azure got zapped in earlier this year. It took them well over 24 hours to get one of their major data centers back up. They had a fire, took out the generators, and they had basically that whole data center was down for a whole day. And as people scrambled to move resources to other platforms, it took them a good 24 hours to get it back up. Obviously, if you've got your own data center or you're working with a cloud partner in a regional area, that's a risk. It's a pro and a con. The bandwidth throttling we already talked about. And of course the cost. And one of the things we discovered from talking to customers about using the cloud is it is very cost effective to a point. And at some point, you start saying, you know, maybe I should look at a private data center, or I should look for a different provider. And the quote literally I got from a customer was, somehow our $100 server budget ended up costing me $1,000 per server. And it was overage charges and having to upgrade to a dedicated server and some of these other things that kind of piled up on that particular customer. So it happens. And if all goes right, you can be like Nick Walinda and make it all the way across Niagara Falls without falling off the wire. So anyway, SBCs in the cloud, I think it depends a lot on the use case. I showed you a few use cases. You have to have a business model to benefit from the scaling, right? I'm assuming, you know, most of you probably do a subscriber-based business if you're doing hosted, and that makes sense. But there are some business models that just don't make sense, that the benefits of scaling just don't match the business model. And of course, pay attention to security threats. You know, having an SBC, obviously, from what I showed you here, hopefully you understand the value of it. And watching the media costs, I think, is very, very important to make sure that you stay away from the right-hand turn and head towards the left-hand turn as you go here. So, got a few things here for you to learn more. One of them is I maintain a blog on Telco Bridges blog, blog.telcobridges.com. I write about this stuff all the time. We also have a whole library of recorded webinars about SBCs and about how they fit into the market and how to use them in the freesbc.com video library. And the best thing is you can give us a try. There is a free version of FreeSBC on, that you can download or you can order on freesbc.com, and that's where we share an Amazon AMI with you that you can use on your own Amazon account, and you can spend some time with it. Or if you like, for a small fee, you can use our account and host it on that. So, all right. So with that, open it for some questions. So, everybody's looking at each other. So.
Somebody's got to have a question out there. Want to work?
Thanks. So, if you want to run a SBC virtualized, would you put that, in your tunnel router or your central router, which would be on your edge network? Because it looks like in all these cases, it would be your central router in a classic Cisco configuration.
Yeah. Well, those are kind of Cisco specific. Generally, the SBC is in the DMZ on the edge. All right. And typically would be in parallel with a firewall that would be used for data services. So it generally doesn't, I think it's recommended in most cases not to put it behind a firewall because the firewall just mucks everything up, but instead to put it in the DMZ in parallel to it.
Okay, yeah, okay. That's kind of what I was tracking with there, because it looks like if you encrypt your RTP and your all your switching, that you'd want to decrypt it before it went off your platform or off your network.
Right, yeah. So in general, matter of fact, that encryption use case we talked about, generally you, when it comes into your data center, you would decrypt it and keep it in the clear once it's inside your data center. And conversely, when it leaves, you would want to re-encrypt it before it goes. Yeah, yeah. That's a good question. Thanks for asking. Okay. Any other questions?
Other questions?
Well, I'd be happy to answer if something pops to mind. I'll be over in booth 301 most of the rest of the afternoon. I want to thank you all for spending some time with it, and I'm going to give you a round of applause for thanking for your comments. So thanks very much.